Hi everyone, this is the September update of Science and Force Fields at Open Force Field, where I summarize some progress we've made over the past month on major projects. First off, we've recently released Sage 2.3 RC1. That is the first release candidate of Sage 2.3, our first force field with a neural network charge model. This charge model, named AshGC, has also been fully released as version 1.0. This is the first instance of using the Nagel charges section in a released force field. AshGC version 1.0 adds native single atom support into the model, and Sage 2.3 RC1 has refit van der Waals parameters with the AshGC charge model, as well as refitting and modifying bond, angle, and torsion parameters, both to fix targeted chemistries, so for example, three-membered rings with an sp2 carbon, as well as fixing a general issue where torsions could apply to central bonds with varying multiplicities, but now only applies to a central bond with a single multiplicity. Sage 2.3 RC1 is not expected to be the final 2.0 release, but it has been released just to enable public access to the AshGC charge model. If you try it out, please do let us know what you think. It does require the OpenFF Toolkit version 0.17, which was also recently released. I mentioned that 2.3 RC1 is not expected to be the final 2.3 force field release. That is in large part because we have been hard at work fitting a second force field candidate that improves performance on particular benchmarks. So over the past month, we fit 4 possible candidates for RC2, where one in particular, version 3 K100 is its working name, seems to show the best performance. We have now benchmarked V3 K100 on 3 of our 4 tiers of customary benchmarks. So that's QM benchmarks, physical property benchmarks, densities and enthalpies of mixing, as well as solvation free energy benchmarks. And to make the final decision on whether or not to release RC2, we are now just waiting on protein ligand binding free energy benchmarks, which are currently being run for us by OpenFE. In terms of other work, Jen has continued work on the Genentech organometallics project, and in the past month, she has generated 3 additional organometallics datasets, each with its own molecules with different multiplicities, with a combined 672,000 structures. So another pretty big dataset that is now slowly making its way through the compute pipeline. This past month, the entire team across OpenFF has actually come together for a cross-training month. The plan was to get everyone working on small projects with an eye towards 4 major goals. Firstly, getting people, especially people in the infrastructure team, interacting with software as users, which will make it easier to identify pain points and solve them. With an expanded team, to integrate review culture and best practice into our scientific efforts. Number 3, to increase skill sets and bus factors across the team so that everyone is broadly aware of the science and the work that we're doing. And lastly, to actually advance our roadmap. So the projects that people are working on do actually feed into and build into major goals that we have identified on our roadmap. These are still in progress, but we're pretty excited about them. I've shown the 4 projects people are working on this page, and they span the gamut from investigating splitting the nitrogen van der Waals parameter, which is being driven by Matt, to using SME to conduct force field experiments. So Jeff is looking at whether we can use our existing open force field QC archive data to train a force field with SME. Jen is working on a different version of autotyping parameters from data, where instead of starting from a general parameter and splitting out, she is starting with hyperspecific Smertz patterns generated from the data for bonds and angles before clustering them into a more general force field. And lastly, Josh is looking at using SME to fit a force field to additional protein data. This has already generated really useful insights, especially on part of the infrastructure team, on where we can improve in our software. And we're looking forward to hopefully presenting some of the more scientific conclusions of these projects, either in science meetings throughout the month or in the ad board update next month. And last but not least, Chapin has been making great progress on the protein force field. So just as a reminder, the goal of this project is to produce a force field with parameters applicable both to proteins and to small molecules. And Chapin has been evaluating the performance of this force field on multiple tiers of benchmarks. The first tier is the performance on short unstructured peptides. The second tier includes both simulating folded proteins in simulation, in long time scale simulation, as well as folding a 15-mer into a helical structure over simulation. And then the third tier is an expanded data set. So far, most of the protein force field candidates that Chapin has evaluated have hit roadblocks in tier 2. But it seems that 2 of the approaches Chapin has been trying has resulted in force fields that are performing relatively promisingly. So the most promising two force fields are called null AAQ-AA3-2 and null former AAQ-AA3. And they're broadly derived from the same approach with a couple of differences. Null AAQ-AA3-2 starts from a force field that was fit first to protein data, so small molecule data and peptide optimizations and torsion drives, and then went through multiple rounds of fitting to NMR data for GB3 before adding NMR data for the 15-mer. And this results in a force field that performs well on tier 1 on short unstructured peptides, as well as the more stable folded proteins of tier 2. The second approach, null former AAQ-AA3, is very similar. Chapin starts from a QM fit, but crucially, he has added an extended dataset of tetramers to the QM dataset. This gives a much better starting point, with the result that a single round of fitting two combined GB3 and 15-mer NMR data results in a force field that performs to a very similar standard as the previous approach. Chapin is now progressing further with ongoing benchmarks of both of these force fields, and hopefully we'll be able to present results next month. Thank you very much for listening.